Some 66 million years ago, a fateful day brought an end to the reign of the dinosaurs, giant creatures that had ruled the planet for tens of millions of years. An asteroid measuring 10 to 15 kilometers in diameter slammed into Earth, creating an explosion billions of times more powerful than an atomic bomb. This terrible collision not only created a global shockwave, but also released a series of fine dust, toxic gases, and sulfuric acid into the atmosphere, preventing sunlight from reaching the ground for many years. At the same time, in the western part of the Indian subcontinent, in what is now the Deccan Traps, a chain of giant volcanoes was also erupting violently, adding greenhouse gases and sulfuric acid to the atmosphere. These two destructive geological phenomena caused a global environmental collapse. Plants died off en masse, the food chain was disrupted, and about 75% of life on Earth, including all non-avian dinosaurs, became extinct. However, in the darkest moments of life, a whole new chapter quietly began. The Cenozoic Era, or Cenozoic, was the period following the mass extinction event at the end of the Cretaceous. In the context of the large creatures being wiped out, smaller, more agile creatures, especially mammals, rose up. Previously, during the time of the dinosaurs, mammals were just dark creatures, small like mice, mainly nocturnal to avoid predation. But now, with the disappearance of giant reptiles, small mammals such as kangaroos, platypuses, anteaters quickly occupied the ecological gaps left behind, evolving and diversifying explosively. In just a few million years after the mass extinction, the number of mammalian genera multiplied from about 18 at the end of the Cretaceous to hundreds at the beginning of the Cenozoic. This explosion was the result of a phenomenon known as evolutionary radiation, when a group of organisms had the opportunity to expand and adapt to a variety of habitats that had previously been occupied. Mammals not only evolved into carnivores, herbivores, tree climbers, burrowers, and more, but also gradually developed key features such as larger brains, diverse tooth structures, and meticulous care of their young, which helped them become the new dominant class of animals on the planet. From the ashes of the dinosaurs, a new era began, the age of mammals, of continuous evolution, and eventually of humans. The Cenozoic was not just the result of a global catastrophe, but also the beginning of a revolutionary biological process. It was at that geological moment that the wheel of evolution took a completely different turn, a turn that would lead to the emergence of Homo sapiens millions of years later. A blow from the sky ended the age of the giants, paving the way for small but intelligent creatures to write the next chapter of life on Earth. Part 1: Paleocene, when mammals began to dominate the Earth. Immediately after the mass extinction at the end of the Cretaceous, Earth entered the Paleocene, the first stage of the Cenozoic. This is when the planet began to recover from the global shock and when ecosystems began to rebuild. During this time, the continents were still drifting. India was moving northward, preparing to collide with the Eurasian continent. Australia was beginning to separate from Antarctica, and the ocean was still unfamiliar to modern maps. Although the habitat was wild and unstable, it was this setting that became the promised land for mammals, a group of creatures that had been overshadowed by the dinosaurs to begin to thrive. What is astonishing is that in such a short time, the number of mammals increased dramatically. From a few dozen genera at the time of the dinosaurs' disappearance, this number quickly increased to hundreds during the Paleocene. Ancient mammals such as the multituberculata, distant relatives of rodents, abounded. At the same time, carnivores such as mesonyx, which resembled wolves but had hooves instead of claws, also began to develop. Notably, mesonyx was initially mistaken for a whale ancestor due to its many marine-like morphological features, but was later determined to be a separate evolutionary branch. These misunderstandings show that the Paleocene mammal world was in a period of great chaos, newness, and diversity that was difficult to classify. However, mammals were not the only ones to colonize the land. The Paleocene Earth also saw some giant reptiles survive and thrive. In tropical regions such as what is now Colombia, Titanoboa, the largest snake ever known, reached nearly 15 meters in length. The seas were also teeming with sea crocodiles like Acherontosuchus and giant turtles like Carbonemys, which had shells over 1.5 meters long. These reptiles, though no longer as dominant as the dinosaurs, still contributed to the extraordinary biodiversity of the early Cenozoic. In addition, one of the most remarkable events of the Paleocene was the PETM Paleocene-Eocene thermal maximum, a period of extreme heat lasting about 200,000 years that caused global temperatures to skyrocket. In Antarctica, the average winter temperature was around 11 degrees Celsius, transforming what is now a tropical paradise of palm trees, giant ferns, and subtropical forests. Both Greenland and Canada were also home to crocodiles and turtles during this period, suggesting that the climate was incredibly warm. This sudden warming allowed for a boom in flora and insects. PETM leaf fossils often show signs of insect-gnawing, evidence that insects once exerted enormous pressure on vegetation. Leaves also gradually changed from serrated to smooth, a classic sign of adaptation to warmer climates. And it was in these warm, dense forests that the first primitive primates emerged. These small, agile tree-climbing creatures, such as Plesiadapis and Tailhardina, are considered to be the initial stepping stones to the rise of humans millions of years later. In other words, the Paleocene was not just the rise of mammals, but also the foundational preparation for the emergence of primates, humans' distant ancestors. A post-dinosaur world was not simply a restoration of life, but also the opening stage for the next great biological revolution in Earth's history. Part 2. Eocene. When whales left shore and primates began their evolutionary journey. As the Eocene epoch progressed, Earth continued to see an explosion of evolution, both on land and in the sea. After the climate peaked during the PETM, the planet remained warm throughout much of the Eocene, creating ideal conditions for many groups of organisms to thrive and expand their ranges. This was also when animals began to evolve in completely new directions, paving the way for the emergence of many of the modern groups we know today. On land, ancient ungulates such as Eohippus, the ancestor of horses, first appeared. Along with them came Diacodexis, a distant ancestor of deer, cows, and sheep with compact bodies and long, slender legs that helped them run quickly through open forests. These animals marked the beginning of the two groups of large modern ungulates, the even-toed and odd-toed. Meanwhile, a quiet but crucial evolution was taking place underwater, where whales first left the continents and ventured into the ocean. The first recorded primitive whale was Pachycetus, a wolf-like creature that lived on land but had already begun to sense sound through vibrations in the ground, a rudimentary sign of underwater acoustic navigation. Just a million years later, Ambulocetus appeared, a semi-aquatic, large-limbed walking whale. It hunted in rivers, wading like a crocodile to attack drinking prey. From there, over millions of years, evolution proceeded rapidly, with species like Rhodositus and Protositus until Basilosaurus, a giant whale that measured over 15 meters in length, appeared. By this time, the whale's body had almost completely adapted to the marine environment, with the forelimbs transformed into pectoral fins, the hind limbs degenerated, and the tail having a horizontal tail fin, a characteristic of modern whales. At the same time, the ocean also welcomed Pasosiren, the first ancestor of the manatee. Initially, Pasosiren were still capable of walking on land on four legs, but gradually evolved into fully aquatic creatures like today's manatees. Meanwhile, modern fish began to dominate the ocean. Groups of fish such as cod sea bass grouper appeared and established a new food chain, replacing the dominant role of the ancient fish species that had gone extinct before. Back on land, the Eocene was also the time when ancient primates began to make a clear evolutionary step. Species such as Adapiforms, which had a lemur-like appearance, appeared in Europe and North America. With their agile climbing skills, developed eyesight, and increasingly sophisticated brains, these primates became well adapted to life in the jungle and opened up a completely different evolutionary branch. leading to the formation of monkeys, apes, and eventually humans. This was a quiet but crucial turning point in evolutionary history, as it opened up the tens of millions of years of journey to form the intelligent species Homo sapiens. And if you find this evolutionary journey both thrilling and awe-inspiring, it's only the beginning. Each subsequent period has brought with it even stranger, more surprising stories, from giant creatures to geological events that changed the face of the planet. Don't forget to subscribe to the channel so you don't miss the next installments in our series exploring the living history of the Earth. Let's continue to uncover the chapters that are still buried in the dust of time. Part 3. Oligocene, when the climate cooled and nature selected the survivors. The Oligocene, which began about 33.9 million years ago, was one of the major turning points of the Cenozoic Era, when Earth abruptly shifted from a long period of warmth to the first global cooling of the Cenozoic. Without the tropical forests that stretched across the high latitudes, the planet entered a period of ice and cold winds. This was also a time when global ecosystems were severely strained. Many species became extinct, others evolved to survive, and a few lucky ones emerged as new dominant forces. The Oligocene world was a harsh but vibrant place, where challenges created superior creatures. In the oceans, the Eocene-Oligocene extinction event dealt a devastating blow to marine life. More than 90% of foraminifera species were wiped out, followed by a severe decline in clams, oysters, corals, and many bottom-dwelling organisms. But it was from that loss that modern marine animals such as early dolphins, bearded whales, Mysticeti, and toothed whales, Odontoceti, began to emerge. They rapidly evolved to adapt to colder waters where sound traveled farther and echolocation became a survival skill. On land, climate change forced plants to retreat. Jungles were reduced to grasslands, deserts, and low-lying shrublands. This created a severe challenge for herbivores. To survive, one group of even-toed mammals, the ancestors of deer, cows, and sheep, developed a unique survival strategy: fermenting stomachs and the ability to chew their cud. These were the first ruminants able to digest indigestible foods like hay through microbial fermentation in their multi-chambered stomachs. According to research by Professor Mitchell at the University of Wyoming, it was this evolution that helped ruminants outperform odd-hoofed animals like horses, which had only a simple stomach, in the race for survival on the cold steppes. One fascinating event of the Oligocene was the unexpected migration of primates from Africa to South America. Despite the great distance between the two continents at that time, somehow a small group of primates, perhaps drifting on rafts of vegetation after storms, crossed the ocean and successfully settled in the new land. This is considered one of the turning points that shaped the primate fauna of the Americas today, including baboons, spider monkeys, and other endemic primates. Meanwhile, in North America, the ancient beaver Paleocastor left a unique mark on the history of paleontology. Unlike modern beavers who build dams, Paleocastor dug spiral tunnels, creating unique fossil structures that were mistaken for devil's tools. Their origins were inexplicable to early scientists. These fossils were later identified as the remains of the ancient beaver's strange underground life, vivid evidence of how ancient creatures responded to changing environments. Part 4. Miocene, when giants arose and primates first set foot. The Miocene, which began about 23 million years ago, was more than just a transitional period. It was the epic stage for the emergence of giant animals, the first tailless primates, and global climate changes that changed the entire biota of the planet. As the Earth cooled after the first Oligocene ice age, ecosystems were reshaped once again. This time with not just new creatures, but also radically different survival strategies. Grasslands began to expand rapidly, gradually replacing the original forests. The dominance of short plants over tall trees created a clear evolutionary pressure. Herbivores needed longer legs, leaner bodies, and faster speeds to escape predators in the open. This environment produced some incredibly unique creatures. A typical example is Chalicotherium, a species that resembles a strange combination of bear horse and ape. With long clawed front legs, they use them not to attack, but to pull branches close to their mouths. Therefore, they moved by holding hands walking, a strange and bizarre gait. No less impressive is the Entelodon, also known as the hell pig. Possessing a body like a pig, but almost as tall as an adult, a large head, large teeth, and a hunting instinct, Entelodon was not only an omnivore, but also an extremely dangerous opportunist of the Miocene. In addition, Stenimylus, an ancestor of the North American camel, appeared with a small body, no hump, and looked like an antelope. But the interesting thing is that the same North American camels would later migrate to Eurasia across the Bering Strait, and in the process of adapting to the cold climate, they developed humps to store fat, a feature that still exists in desert camels today. This suggests that the hump was not a product of the desert but a relic of an earlier ice age, a paradoxical but powerful fact. During the same period, giant birds ruled the skies and the land. Pelagornis, with a wingspan of up to 7.4 meters, was the largest known flying bird, even surpassing Argentavis. Its strange feature was its beak, which had tooth-like structures, not real teeth but bone growths used to grip slippery prey like fish. On the ground, the Forus racidae terror birds, flightless, 3-meter-tall, fast-running, and powerful pecked birds of prey, terrorized the South American savanna. They were proof that even though dinosaurs had gone extinct, their surviving descendants still managed to dominate the land in their own way. But perhaps the most important evolutionary event of the Miocene was the appearance of the first tailless primates, the direct ancestors of humans. About 23 to 16 million years ago in East Africa, the proconsul emerged. Although not yet classified as humans, proconsuls had many anthropomorphic features, such as a quadrupedal gait, lack of tails, and a jaw structure similar to that of modern chimpanzees. They were considered the transitional link between monkeys and apes, the first step in the millions-year journey to Homo sapiens. Part 5. Pliocene, when the continents joined and humans emerged. The Pliocene, which began about 5.3 million years ago, was a defining chapter in evolutionary history, not because of strange creatures or giant biomes, but because of the shaping of modern continents, the biological interchange between continents, and above all, the first clear appearance of human ancestors who could walk upright on two legs. It was a time when the world stopped moving randomly and began to fall into place to form the modern ecosystem we live in today. One of the most important geological events of the Pliocene was the joining of North and South America via the Isthmus of Panama. Before that, the two continents had been separate with completely different biomes. The connection between the two giant landmasses triggered a massive intercontinental biological migration, also known as the Great American Biotic Interchange. The strange thing is, North American species such as wolves, wildcats, horses, and elephants easily spread to South America and established dominance, while the number of South American species such as ground sloths, giant pangolins, and armadillos that remained in North America was very limited. The reason for this one-sided phenomenon remains a mystery. One hypothesis is that South American species which evolved in isolation were not strong enough to compete with North American species that had been tempered by more severe climates. Or perhaps North American species had advantages in physical strength, hunting ability, and adaptation, allowing them to quickly dominate new ecosystems. While the continents were reuniting in Africa, a silent revolution was taking place. The appearance of Australopithecus, the direct ancestor of modern humans. Around 4 to 3 million years ago, the dry, barren lands of East Africa became a great testing ground for a completely new way of life walking on two legs. Australopithecus afarensis, whose famous representative is the fossil Lucy, not only walked upright but also used simple tools, interacted socially, and adapted to semi-desert life, Walking upright not only allowed for better visibility in grassland environments, but also freed up the hands, paving the way for complex crafting, hunting, and communication behaviors, traits that would later shape our identity as humans. Not only did climate change during the Pliocene continue to create more open ecoregions, where savanna, scrub, and woodland replaced dense forests, these were ideal environments for agile long-distance and group-oriented animals. Primates began to develop more clearly defined social structures and to form alliances and defend their territories. These changes, though small in time, were fundamental to the development of early culture, body language, and social cognition, traits that define modern humans. In the north, the Earth began to show the first signs of an ice age. Although not as extreme as the Pleistocene, the constant temperature fluctuations of the Pliocene forced many animals to adapt to long winters, cold winds, and sparse vegetation. Hoofed mammals such as deer and elk began to grow large antlers for survival and mating, while carnivores such as lions, bears, and wolves gradually developed the instinct to hunt in packs. This was the period when the first social structures emerged, not only in primates, but also in the wildlife, reflecting the need to survive in an increasingly unpredictable world. The Pliocene was also the period when the modern geography of the Earth was almost complete. Ocean currents became more stable, and climates began to clearly divide between equatorial, temperate, and polar regions, creating conditions for regional specialization of organisms. These factors contributed to the formation of biogeographic regions that still exist today, such as the African, tropical American, and temperate forests of Eurasia. Part 6. Pleistocene. The Ice Age and the Rise of Homo sapiens. The Pleistocene, which began about 2.58 million years ago, was not a peaceful period for the planet. The Earth entered a cycle of extreme climate where severe ice ages rolled down from the poles only to relent between brief periods of warming known as interglacials. This was no longer a world of lush rainforests or vast grasslands. It was a fierce battle for survival between giant animals and the first groups of primitive humans who began to pick up tools, light fires, and look to the future. The landscape of the Pleistocene was a grand one. Across the frozen tundra and steppes of Europe, Asia, and North America, prehistoric monsters such as the woolly mammoth, the coelodon, the smilodon, the arctodus, and Megatherium, a giant ground sloth larger than a pickup truck, roamed the tundra and steppes of Europe, Asia, and North America. These creatures were remarkable not only for their size, but also for their perfect adaptations to cold climates. Thick layers of fat insulating fur, long canines, and curved claws were all survival tools that nature had refined over millions of years. But the most remarkable thing about the Pleistocene was not the size of the animals, but the emergence of a small, weak, fangless, furless, and intelligent species, Homo sapiens. Around 300,000 years ago in Africa, the first modern humans began to appear with more sophisticated stone tools, the ability to coordinate hunting in groups, and especially the ability to communicate information in primitive language. Without needing to be as big as elephants or as fast as wolves, Homo sapiens entered the race for survival with a weapon that no other species had: imagination and the ability to learn from experience. As they advanced into the Pleistocene, these groups of humans migrated across continents. They crossed the African savanna, crossed the Middle East, reached Europe, Asia, and finally reached the Americas via the Bering Strait when sea levels dropped. Along the way, they encountered and competed with other human species such as Neanderthals in Europe, Denisovans in Asia. This competition did not necessarily mean war, but it was the ability to adapt to create tools to organize a flexible society that made Homo sapiens the last remaining species, a species that could stand in a snowstorm and still make a fire, a species that could remember the location of a water source for generations, a species that not only knew how to adapt to the environment, but also knew how to change the environment. However, the victory of Homo sapiens also marked the beginning of the mass disappearance of large animals. From 50,000 years ago to the present, almost all megafauna, That is, animals weighing over 1 ton have disappeared from every continent except Africa. In North America, mammoths, saber-toothed tigers, and ground sloths all became extinct. In Australia, giant kangaroos, giant lizards, and carnivores, such as Thylacoleo, all disappeared within a few thousand years of the appearance of humans. The cause remains a matter of debate among scientists. Was it climate change, or was it the relentless hunting of primitive humans? Although there is no definitive answer, the timing of the expansion of humans and the extinction of large animals cannot be ignored. By the end of the Pleistocene, about 11,700 years ago, the last ice age ended, ushering in the current warm period, the Holocene. Rivers stabilized, forests flourished again, and Homo sapiens shifted from a hunter-gatherer lifestyle to agriculture. From stone huts and campfires in the snow and ice, humans began to build villages, cultivate crops, domesticate animals, and begin a civilization. All of this began in the Pleistocene, where a weak species that had once been forced to hide in the shadow of mammoths eventually rose to become the creatures that controlled the entire planet. Part 7: Holocene, Warm, Civilized, and the Last Giants. The Holocene, Earth's current geological epoch, began about 11,700 years ago, shortly after the end of the last Pleistocene ice age. With the melting of glaciers, the global climate became more temperate and stable than ever, a golden age for human biological, cultural, and social development. But at the same time, it also marked the end of a glorious chapter in the history of life, the disappearance of the last remaining giant animals on Earth. Creatures that had survived many ice ages but could not survive the changes brought by humans. The biological landscape of the early Holocene was a world that was still very different from today. In the northern hemisphere, forests were slowly regenerating, spreading across Europe, Siberia, and North America. In these regions, there was once a majestic presence of hairy monsters such as woolly mammoths, woolly rhinoceroses, saber-toothed tigers, short-faced bears, giant ground sloths, megatherium or giant iron-shelled armadillos, glyptodon, with shells as hard as tanks. In the Americas, the giant deer Megaloceros with antlers up to 3 meters long, or the giant dire wolf, a species that made hunting groups wary, still have a strong presence. These are creatures that have survived millions of years of climate change, but strangely gradually disappeared when modern humans began to expand their territories, use sophisticated tools, and form social communities. The cause of this wave of extinction remains a scientific mystery without a definitive answer. There are two main hypotheses post-glacial climate change which caused abrupt changes in habitats and systematic human hunting, especially in places like North America, South America, and Australia, where humans had only appeared a few thousand years before the extinction. Studies show that the disappearance of megafauna often occurred soon after Homo sapiens set foot on each continent, in a hauntingly repeating pattern. This coincidence has led many scientists to believe that human hands were the key factor, whether directly or indirectly, that pushed the giant creatures to extinction. However, that loss also came at the price of the rise of civilization. Entering the Holocene, Homo sapiens no longer lived on simple hunting and gathering. They began to cultivate domesticate animals, build riverside villages, develop tools and language. The advent of agriculture in Mesopotamia, the Nile, the Indus-Gangetic Basin, and the Yellow River marked a major turning point. Humans no longer lived in nature. They began to recreate and dominate it. Small villages gradually transformed into cities, then empires. Farms were organized, forests were cut down for farming, and wild animals were gradually replaced by domestic animals, from dogs, cows, pigs, to sheep and horses. Ironically, human progress also had long-term consequences. From the Holocene onwards, human activity began to leave a distinct mark on climate and geology. So much so that today many scientists argue that we should call the current era the Anthropocene, to reflect the dominant role humans have played on the planet. The rate of species extinction over the past 200 years is dozens of times faster than the natural rate. Global temperatures are rising, sea levels are rising, ice is melting, ecosystems are being disrupted. All are indirect consequences of Homo sapiens' own production and consumption. However, the Holocene is not only a story of loss, it is also a story of the extraordinary adaptability, creativity, and evolution of a species, humans. From a few thousand scattered individuals, Homo sapiens has developed into a global social network of over 8 billion people, spaceflight technology, genetic research, and the creation of artificial intelligence. But at the same time, humans are facing the survival problem they themselves created. Are we wise enough to live sustainably on a finite planet? Part 8. From the post-Holocene to the future. When evolutionary history turns a new page. After more than 11,000 years of relative stability in the Holocene, humanity is now facing an unprecedented transformation, not caused by a cosmic catastrophe, not by glaciers or volcanoes, but by human actions. Many scientists have begun to warn that we are no longer living in the Holocene, but have entered a completely new era where the human footprint has become a geological factor, the Anthropocene. This is no longer a story about humans living in nature, but a story about humans becoming a force that is remaking nature, even destroying it. The clearest sign of this transformation is the rate of mass extinction. During the past millions of years, natural extinctions occurred very slowly, often taking tens of thousands of years to replace old biological systems with new ones. But now, scientists estimate that species are disappearing at a rate hundreds to thousands of times faster than the natural baseline. In less than 200 years, coral reefs, pristine forests, and many endemic animals and plants have disappeared, largely due to deforestation, pollution, overfishing, and human-caused climate change. What's scary is not the numbers, but the silence. The world is losing biodiversity with little notice. At the same time, another factor is reshaping the course of evolution: technology and artificial intelligence. Since the emergence of Homo sapiens, biological evolution has been a slow process over hundreds of generations. But now, with AI gene editing like CRISPR robots and machine-talking brains, humans are gaining the ability to rewrite their own genetic code. This raises an ontological question. Will Homo sapiens survive in the biological sense in a few centuries, or will it be replaced by a new form of life? A post-human, a combination of biology and technology. If that happens, the period of slow evolution for millions of years will end, and in its place will be a form of evolution driven by humans surpassing all the limits that nature has ever set. In addition, recent climate changes have made many scientists worry that the Earth may enter a new super ice age, or conversely a tipping point, where permafrost melts, sea levels rise, and global climate systems collapse. If that happens, humanity will not be facing dinosaurs, mammoths, or saber-toothed tigers, but the collapse of the systems on which it depends: freshwater, agriculture, food supply chains, and energy. Unlike previous ice ages, survival is now not just a matter of biological adaptation, but of the survival of an industrialized civilization. Not all doors are closed, however. Artificial intelligence, renewable energy, carbon storage, and biosphere restoration all are potential pathways to bring the planet back to balance. But to do so, humanity needs an evolution that is more important than any genetic change, an evolution of thought, morality, and community awareness. We need not just a few superhuman individuals, but a global culture that respects ecological limits, restrains blind exploitation, and redefines the meaning of development. In other words, if the Pleistocene is a war with nature, the Anthropocene is a war with ourselves. And one day, the current era will end, as all previous eras have. Will humans make their mark as a highly evolved superspecies, or will they become a new fossil alongside dinosaurs and mammoths? Will future generations of Homo sapiens, if they survive, look back on this era as a peak or a tragedy? The answer is still being written every day in your actions, mine, and the actions of an entire civilization. Share your thoughts in the comments section, and don't forget to follow the channel to discover the untold stories of the Earth.